Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by cutting power and checking basic electrics to avoid damage. Use a multimeter to verify the power supply output. If the supply reads 0, the fuse or adapter is likely bad. Once done, remove the fuse and check continuity, then inspect the PCB for obvious damage or swollen components because of visible fault speeds repair. Make sure to document connector positions and take photos before removing panels so reassembly is straightforward. And label screws as you go. You now follow the signal flow to isolate the fault. Start at an input and inject a test tone, then listen or use an oscilloscope at each stage so you can locate where the sound drops or distorts. If one channel fails, compare components and voltages to a working channel because matched stages reveal discrepancies. Once you identify a bad op amp, capacitor, or dry joint, plan the replacement or reflow. Make sure to use correct polarity and temperature-controlled solder to avoid thermal damage. You finish by swapping the defective components and reassembling the mixer in the reverse order you disassembled it. Power up with a current-limited supply if possible, then run a full test using headphones first, then speakers at low volume while monitoring for noise, distortion, or overheating. If everything is stable, do a channel sweep and EQ check to confirm performance across frequencies. Troubleshooting tip: if noise or hum remains, recheck ground connections and shielding, and perform a wiggle test to uncover intermittent solder joints.
Thanks for watching. Subscribe to keep your life in tune.